Alright, so today, as you've already seen, it's all about scripting. So most of the stuff are command line tools or Python tools we are looking into right now. And let's start with the get color checker values one. So as you can see, I just created a folder anywhere on my hard drive. I named it this time get color patches for this tutorial, but of course you can name it after, for example, the target you want to match to. Or for example, I did a EXR200T, so you can name the folder that way. And then I'm setting up folders with my Alexa image, which is my source camera. You know how to prep charts already, and you can get a lot of them in my shop. So for example, you can get ARRI charts, you can get a ton of motion picture charts, you can get a ton of photo stock charts. And as of today, you can also get these ones, but I will touch on that in a minute. So then you prep it for your color space and color management workflow however you want to. So for example, for DaVinci White, Gamut for Aces, whatever, or you just leave them as ARRI, so log C3, and basically a conversion just to the film profile, so more or less to Cineon. And what you want to do is you have your 0 exposure value, and you can have just one in here, or you can have multiple ones. As you can see, I have here -1, 2, 3, +1, 2, 3, and 0 exposure value in here. You can have it from -5 to +5. You can have just one, however you prefer. The important thing is that you have another folder. These are my film images, which is my target. And on one hand, you have to have the exact same number. So as you can see, I have -1, 2, 3, and +1, 2, 3 in here, and also the 0 one. And furthermore, they have to be in the exact same order. So -1, 2, 3, -1, 2, 3, +1, 2, 3, +1, 2, 3, and the 0 one. That's important because if you run the script, which we will do in a minute, you will get lines of color patches, and they have to line up, obviously, because you want to match the -1 to the -1 and so on and so forth. All right. And another thing that you've probably have seen already, I cropped the images. So you have to crop really to the border of the color patches and make them straight. I did this with Photoshop. So I cropped to the border and aligned them so they're more or less all the same and pretty straight, or at least as good as possible. I think you can do an even better job, but I think you get the meaning just with these ones now. And furthermore, I also blurred the image a bit so that you average it out and you don't have too much noise in it. And when you're done with these two, you have this command line tool in here. And to actually trigger this, you have to go to the terminal. So this is my terminal. And now I want to head to this exact location. So first thing I do is type ls, and then I have all my directory in here. And then I go to CD documents, because that's in my document folder. And as you can see, now I'm in documents. Then I want to go CD get color patches. Now I'm here. And what I have to do now is to actually trigger the script. So what I want to do now is hit / get color checker values and hit space. And what I want to do now is I want to do this folder and hit Alexa _ images, and then do a -R space -O space and call it Alexa _ dataset _ new, just that we have another one, and make .txt because I want the text file. And what I'm doing here is, because I have multiple exposure brackets, I want to have this R in here, which is recursive, and I want this O, which is the output name. So basically the recursive is going through all the images that are in this folder from top to bottom, and don't just do one. And the O is the name of the dataset. Now I hit enter. As you can see, it's reading image, reading image, reading image. That's all the images I have here. And then I have Alexa dataset new in here, which is amazing. As you can see, this is my dataset. Lots of points, so RGB for basically the first patch in the first image, and so on and so forth. And that's amazing, because if I read them manually, that would take way, way longer, as you can imagine, or maybe have done so already. And that's also the important part, why the images in here have to line up with the images in here, because as you can see, then this line gets matched to the other line, and so on and so forth. Of course, you have to do the very same thing with the target one too, but as we're in the, you say, Alexa, you can read this and save it as a CSV. So then you have this very same thing in a CSV file, which we will need for the color match in a minute. And if you have the wrong delimiter, which can happen with the CSV, I'm also uploading this small Python script where the delimiter is changed so that it's actually reading the file correctly. And that's basically it for getting the color patches. So super easy and straightforward, very fast and efficiently. And see you in a minute in the next one where we will use these datasets. All right, now you can either download the camera match Python script and install everything with VS Code, for example, or you can use it within the browser. I also have this link for you in the written part of the tutorial, and it's very easy. So for the first time, I would suggest to stick with this one. So the first thing you have to do in here is just hit play, and then it installs all the needed libraries. And if you want to learn about it, you can see the code in here. And as you can see, it takes some time. All right, now it's done. And it's super easy, because now you can just go to upload source data, again, run the cell, choose your file, which is in here. So the source is our Alexa dataset. And I take the reformatted one because that has the right delimiter. As you can see, uploaded source data successfully, and upload the target. So take the film dataset, the reformatted one, open it up, done. Here you can use the test data if you don't have some, but we have some. And now we just want to create the LUT. And in here we're using the RBF function, which is the radial basis function. And honestly, I always use this one because I think it's a very good interpolation, a very nice function, and I totally love it. And rumors are that also Filmbox is created with the RBF function and interpolation. And as we probably all know, or a lot of you know, is that Filmbox works very nice and the profiles are very robust and nice. So why not stick to this and also use the RBF function? And to be honest, I got a lot of amazing LUTs out with this RBF function already. So let's run it real quick. Again, as you can see, you just have to click play, and that's now my LUT. Looks similar to Lattice, really nice that the plots in here. And as you've probably seen in the file names, this was a creative scan, so I tried something crazy and I didn't also prep the charts very nicely for this tutorial. I just wanted to do it real quick and push it out so that you see how it works. But if you prep it better and adjust the black point and don't use a creative scan, you get an even nicer result. But even this one is really amazing for this creative thing that I wanted to try and see how it looks. And now you can just save a LUT and call it whatever you want to. But it's always good to use a descriptive name like so. And once again, hit play. And as you can see, it's downloading the LUT, and you have a finished LUT file that you can use in Lattice to verify or smooth or adjust, or just load it into Resolve and see how it goes and how it looks. And of course, if you just want to have a matrix, for example, a 3x3 matrix, you can also use this one. But usually then it's enough to have just a 0 exposure value. And I would do both charts in linear. Then you can use this matrix and use the matrix in linear within Resolve. It's also really amazing, really straightforward, very fast and efficiently. And basically that's it already. So we created a lot, as you can see in, I don't know, 10 or 15 minutes. Of course, if you have to prep the charts, it takes a bit longer, but also once you have your source, you just have to do it once and then just do all the different targets. It's super straightforward. You can create LUTs with a lot of exposure values, super fast, very precisely, amazing. I really love these two tools and I hope you will so too. And last but not least, because of the EXR200T hint already, this is a very similar stock. It's basically the successor of the one that they used for the Joker emulation. And of course, this stock is very old already. So I have shot it in ISO 50 to come up with the aging because it's from the 90s. But you can also buy this as a special pack in my shop from now on. And I also included another Eastman stock, which is very rare. It's the 100T stock. And yeah, it was super hard to source this stuff and to process it. But I opened up a film lab this year. It's called unwindfilms.at if you want to look into it. And if you're from within the EU, you can even buy some of the EXR stock for yourself to shoot on stills camera, and you can shoot some reference images outdoors or also charts, however you prefer. And within the bag, you will get the creative scan, which is this one where I didn't set the black correctly and wanted to see how it looks, and also a normal scan as it should be. And there are other tutorials coming up soon with a new approach how to prep these charts that I found out. So stay tuned. Get the charts in the shop if you want to. I totally love the Eastman stocks and how they render. Very amazing, very nice images. And also let me know how you like this approach with the scripting and generating the LUT this way. I teach this over a year ago in the Film Emulation Live Masterclass and the people really loved it. So I hope that you all will love it too. So thanks for watching and see you soon in the next part of this journey. Bye!